So in this video, we are going to learn how to find the relative max and min by hand, okay? Without having to use any stinking calculator, right? Now, this is known as the first derivative test. The first derivative test, we let f be differentiable on an interval and let c be a critical number in the interval. If the sign of f switches from positive to negative at c, okay, so the sign of f changes from a positive to a negative at c, then what do we know? Well, if it's positive, that means it's going uphill, right? And then if it's negative, it's decreasing, going downhill. So what type of value do we have? We've got a relative maximum. Okay, so that's the first derivative test. If the sign switches from negative to positive, okay, so if it's going decreasing, 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 and then it switches to increasing, 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 then what do we have here? We have a relative minimum. Okay, that's what this says. If f prime is positive before and after, then f of c is not a relative extrema. So maybe like you've got this c value here, and it's positive, it's going up, 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 and then it stays positive and it's going up, 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 then it's not a relative max or a min. And then same way if we have a negative going downhill, negative, 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 and then negative, negative again, then we see there at this point C that there is no relative extrema. So the only way we have a max or a min is if I'm switching from positive to negative, or if I'm going from negative to positive. Okay? Get all that junk off of there. All right. So we're going to do an example. So we're going to be given the domain of f. I want to find the critical numbers of f. Create a number line to determine the interval on which f is increasing, decreasing. Use the first derivative test to determine whether each critical point is a relative max, relative min, or neither. So we're putting everything that we've learned so far into one problem. Okay, so let's do first with f of x equal to x squared plus 8x plus 10. Okay? Now, the domain of f is all real numbers. Why is it all real numbers? Because this, my friends, is a parabola. Parabola has a domain of all real numbers since it's a polynomial. Now, first thing I want to do is I want to take the derivative, set it equal to 0, because then I will be able to find the critical numbers. So the derivative f prime of x is equal to the derivative of x squared is 2x. Derivative of 8x is, well, I guess it's just 8. And then the derivative of 10 is just 0. So I'm going to take that derivative, which this, by the way, is a line, which is also continuous for all real numbers and differentiable and all that good stuff. So therefore, you can't have something where it doesn't exist. So I just set it equal to 0, and I'm going to solve for x. How do I solve for x? Minus 8, minus 8. And I have 2x equals negative 8, divide by 2, divide by 2. And so I get x equals negative 4. So x equals negative 4 is a critical number of f. Okay? So this is a critical number of f. So the first part, find the critical numbers of f. Got it. There's only one. Pretty easy. Now I want to create a number line to determine the intervals where I'm increasing and where I'm decreasing. So let's make a number line, okay? And on this number line, I'm for sure going to get the mark 4. And what do I know? The derivative equals 0 at 4. So this number line represents outputs of the derivative. Okay? So, what do I need to do? Well, if I think back to my steps on how to find where it's increasing and decreasing, I set it the derivative equal to 0, get the critical numbers. I break up the interval by the critical numbers. I've done that. Now I pick points on the subinterval. So I need to pick a point over here and I need to pick a point over there. So let's pick points. So I want to pick something on the left side of 4. Guys, it does not matter what number you pick. Just pick something. So I pick -5. Okay, if I plug in f prime of -5, I get 2 times -5 plus 8. That's equal to, well, 2 times -5 is -10 plus 8, that's -2, which is less than 0. These are negative values for my derivative over here. That means that I'm decreasing, okay? Now let's pick something on the right side. I don't care what it is. Oh, I'm sorry. I've made a mistake here. This is -4. This should be -4 here. Sorry about that. You're probably screaming in your computer like, why didn't you write that, Mr. Clark? Well, I made a mistake. Sorry, guys. Okay, so this is going to be 0 here. You can pick any number you want. If you wanted to pick -3.9, you could have picked that. Now, I don't suggest doing that because that's kind of a little bit harder to plug into your formula. I mean, I love plugging in 0 because if I plug in 0, guess what? The terms that have x's go away, and then all I have left here is 8, which is a positive number. All I care about is that it's positive. It's positive, it's greater than 0, it's negative, it's less than 0. So this is positive on this side here, so what does that mean? We're going up. So whenever I set this up, and this is exactly how I want you to set up your, I want to see all of this work when you work through this, right? So when you look at this, you see this scenario going on like that. You set it up like this, you're going to know automatically, you're thinking, okay, looks like this is going to be like a relative minimum, right? So we're not quite there yet, okay? So right now, we're figuring out where is it increasing, where is it decreasing, on what intervals. Okay, so f is increasing on what intervals? Well, it's increasing for values that are greater than -4, so from -4 to infinity. And it's decreasing for values that are less than -4. So f is decreasing on -infinity to -4. Okay? So, conclusion here. What do we know from the first derivative test? Well, okay, look. Use the first derivative test to determine whether each critical point is a relative max, relative min, or neither. It's only one of these 3 things. Those are your 3 options, right? So what's happening here? I'm switching from negative to positive. Well, what does this mean? If I switch from negative to positive, my derivative sign switches from negative to positive, I have a relative minimum. And you can see from here, definitely it's going to be a relative minimum. So what do I say? Since, you got to write this out, since f prime of x switches from negative to positive at x equal to -4, then f of -4 equals, well, if I plug a -4 in here, I get -4 squared plus 8 times -4, and then plus 10. So that's going to get me 16 minus 32 plus 10. And that's going to be what? -6. Okay. Then what? Then f of -4 equals -6 is a relative minimum of f. Okay? Relative minimum of f. So now we've done all three. Now I want to do one more example just to make sure that we've got this going on. So that one was a pretty easy one. It was just a quadratic. We know quadratics are pretty easy peasy. -4 and -6, right? So the vertex was here. And so you can clearly see, yeah, on one part it's decreasing, on another part it's increasing. And so you've got that relative min going on there. Okay? Now, let's do one more. F of x equals x squared over x squared minus 9. Okay? So the first thing I want to do is I want to find the domain. So with the last one, it was all real numbers because it was a polynomial. This one's a little bit different. I have a denominator that has variables in it. So what do I need to do? I need to set the denominator equal to 0 to figure out where the undefined values are. So if I set this equal to 0, I have x squared, and I add 9 to both sides. X squared equals 9. I square root both sides. I get x equals plus or minus square root of 9, which is 3. So I have values that are good, and I have two values that I want to avoid. So I want to avoid -3, and I want to avoid 3. So that means it's good everywhere else. So in interval notation, what's that look like? The domain of f is what? It's -infinity to -3, union, -3 to 3, union, 3 to infinity. Okay, that's these areas right here. Okay, since f is a rational equation. Now, what are critical values? Well, that's where the derivative is equal to 0 or does not exist. Okay, so I need to take the derivative. So how do I find the derivative? Well, it's the function is x squared over x squared minus 9, right? So that's a quotient rule. The derivative is equal to low d high. So low is x squared minus 9 times d high, which is 2x. Low d high minus high d low. Derivative of the denominator is 2x. Okay, derivative of 9 is 0, right? All over the square of what's below, x squared minus 9 squared. Okay? So, yikes. Now, x squared minus 9, if I set that equal to 0, I get plus or minus 3, right? Now, if I were to square x squared minus 9 and square 0, okay, this is like setting x squared minus 9 equal to 0 twice. Okay, so you're still going to get the same answer. It's just that your multiplicity's doubled up. So you get 2 answers of 3, 2 answers of -1, or -3. Okay, so still where it does not exist is when the denominator is equal to 0. That does not exist, right? And then where you have a 0 over a number, that's where it's equal to 0. So I need to simplify this numerator here. Okay? If I multiply this out, what do I get? I get 2x cubed minus 18x. And then here I get minus 2x cubed. So these two gulp each other up, and I'm left with negative 18x in the numerator, and then x squared minus 9 quantity squared in the denominator. So the only way this numerator is equal to 0 is in the scenario that negative 18x equals 0, which implies that a number times negative 18 equals 0, well, that number has to be 0, okay? The only way we're in the 0 in the denominator, we already found that, whenever x equals plus or minus 3, okay? So what are my critical numbers for f? The critical numbers are -3, 0, and 3. All right. So I'm going to draw my line. Okay, I'm going to draw my line, and I'm going to put 3 marks that are important. -3, 0, and 3. Okay? Now what do I need to do after I draw my line? I need to find points in between. I need to pick points in between, because what do I know? At each of these, oh, actually it's not equal to 0. It does not exist here. It does not exist. I'm sorry. Yeah, it does not exist here, but it is actually equal to 0 there. Okay, so those are my critical, those are the critical numbers, right? Those are the critical numbers. And now I want to find numbers in between those numbers. Okay, so what's in between? Well, -4 is to the left of -3. -1 is between those two. 1 is between those two, and 4 is between those two. And look, guys, I could pick 40. If you wanted to pick 40 or 400, that's perfectly fine, right? Doesn't matter. You just need to pick something and then plug it in, okay? So what am I plugging into? Remember, this is a graph of the derivative, okay? So the derivative, once again, the derivative, f prime of x, is -18x over x squared minus 9 squared. Remember, that's nasty, right? Okay, so if I plug in a -4, if I do f prime of -4, what do I get? I get a negative number times a negative number over something that's squared. So I don't care if this is a positive number inside or a negative number inside. What happens when you square a number? That number becomes positive in the denominator. And I multiply a negative times a negative, I also get a positive number. So this is equal to a positive number here. Okay? Let me move this down here so I have more room. So that's definitely a positive number, which is greater than 0. So if f prime of -4 is greater than 0, what does that mean? I'm positive, 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 positive. I'm increasing here. Okay? I'm increasing there. Now, for the next part, if I plug in f prime of -1, well, that's going to be what? Negative times a negative over, remember, some number squared. That's going to get me, well, negative and negative makes a positive, divided by a number squared is a positive. So this is also positive. So this is positive too. Interesting. So that's positive. But look, there's a critical number in between those two, right? But it's still positive. Okay? It's still positive. All right? Now, this next part here, I'm going to plug in f prime of 1. And so what is that going to be? Well, that's going to be -18 times a positive 1, right? That's a positive 1 divided by, and then we don't even care what that is because that's a positive number. Now the numerator, negative and a positive make a negative, but the denominator is positive, so this is overall a negative number. So what do I know? F prime of 1 is actually negative. It's less than 0. So this is negative in here, so that means I'm going downhill here, okay? And then I have a does not exist, and heck, if you want to plug in 400, great. It doesn't matter, just plug in something bigger than 3, right? So f prime of 400, if I plug that in, I have -18 times a positive 400 over a number squared. I don't even care what the number is squared. I know it's going to be positive when I square it. So I have a negative number times a positive number over a positive number. That gets me a negative. So that tells me f prime of 400 is negative. So that means I'm negative, 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 negative. Just like this. So this is a weird scenario, right? Usually what we've been seeing is like up, down, going up, right? Okay, never mind. But anyway, this time it's like up, pause, down, right? That's kind of the scenario that's going on here. So what do I know from this information? F is increasing on negative infinity. Where's it increasing? It's going uphill here and here. So that's going to be from negative infinity to 0. Okay? But there's an issue. There is an issue here. Okay? What is the issue? Well, the issue happens to be that we actually stop for a moment at -3. Okay? We stop for a moment at -3. We're not increasing, it doesn't exist. So technically, we have to break this up into 2. Okay? So what is it? Where is it increasing? Negative infinity to -3. Union, we skip over -3 because it doesn't exist there. And then -3 to 0. Okay? So you need to be careful. These are important here because it doesn't exist. It's not defined there. You can't be increasing there. Now the second part, let me do in green, decreasing is, so the function decreases on what interval? Well, we're going downhill and we stop, right? And then we go downhill. So what is that going to be? That goes from 0 to 3, stop, jump over 3, and then from 3 to infinity. Okay? And then from 3 to infinity. Now, what do I know from the first derivative test? The first derivative test tells me this. Since f prime of x switches from positive to negative at x equal to, well, where does it go from positive to negative? It's positive, then it turns negative. So x equal to 0. Then f of 0, well, what was f again? F was x squared over x squared minus 9, right? So that's 0 over -9, which is 0. Then f of 0 equals 0 is a relative max of f. Okay, a relative max of f. Okay? So that finishes off that problem there. Pretty interesting stuff.